Good afternoon, everyone. My name is Drew Fiornelli, and I'm with GITA, and I'll be your host this afternoon for our webinar series on the new U.S. Datum. Before we get started with Dan Martin from the National Geodetic Survey, I'd like to go through a couple of things about GITA with you. First of all, I want to welcome you this afternoon. We appreciate your time. Welcome you back from a great Thanksgiving holiday. And for those of you that are not current members of GITA, I want to encourage you to research the organization and look a little more into it, and hopefully you'll find that we're your professional organization of choice if you're a GIS professional. I'm interested to hear from those of you that are tuned in this afternoon on other topics that you might like to hear in this webinar series. We're starting to fill out our calendar for 2018, and we want to make sure we're putting out content that's important to you or is something that you're interested in hearing about. So any feedback you could provide for us, that would be fantastic. We've already got our December webinar lined up for December 19th. We've got Cy Smith coming back to talk to us about the Geospatial Data Act. There's been some changes that have occurred, and we want to make sure that you're aware of what's going on with the Geospatial Data Act, what's changed and how it could affect you. With that, I want you to know that everyone's microphones are muted when you come into the room, so I want to encourage you to use the chat window if you have any questions for Dan Martin, and we'll address all of your questions at the end of the presentation. With that, let's get into Dan a little bit. So Dan Martin works for the National Geodetic Survey and has been the Northeast Regional Geodetic Advisor since May of 2015. As the regional advisor, he instructs local surveyors, state and municipal agencies, and the geospatial community at large on how to use and preserve the National Spatial Reference System, and provides liaison between the National Geodetic Survey and several states in his territory and federal agencies. He worked in the Route Survey and Geodetic Survey sections of the Vermont Agency of Transportation from 1988 through 2003, and held the position of Geodetic Program Supervisor for the agency from 1999 through 2003. In 2003, Dan began his career with the Geospatial Geodetic Survey as the Vermont State Geodetic Advisor. Dan is a past president and fellow member of the American Association for Geodetic Surveying, AAGS. He is also a member of the Vermont Society of Land Surveyors and the New Hampshire Land Surveyors Association. Tell you what, Dan, before I get to you real quick, I forgot about what I've got on the screen. GITA Phoenix 2018, May 5th and 6th. Guys, I want you to check it out. This may be something you're interested in. And hey, if you're in an area that experiences very cold climate around March, it may be a good opportunity to go out to Phoenix and learn some new stuff about what's going on with GITA. All right, with that, that's my pitch. Dan, I'm going to turn it over to you so you can help us figure out what's going on with this new datum.
All right, thanks, Drew.
All right, so you are now the presenter, sir. There we go.
You should see my main screen now.
Yes, sir. You're up. You're ready to go.
Great. Thanks, Drew. Welcome, everybody. Thanks for attending this webinar. Hopefully, we can get some good dialogue going between NGS and the geospatial community at large. When Drew and I talked earlier today, I admitted that NGS has been pretty good and pretty proactive with reaching out to the surveying and engineering community relative to some upcoming changes for the U.S. coordinate frame, and probably haven't been as good as we should have been with the GIS community. And so hopefully this information is going to be useful to you folks, and you can spread the word, and we get your feedback. The feedback from the users is very important for us. My agency's role is to define and maintain the National Spatial Reference System. To a great extent, we're not users of our data. We create the systems for other folks to utilize. So having the input from the user community helps us to make sure that we're meeting your needs. So with that, let's get started. So just the session objectives. I think the first bullet you all are familiar with, because I think that was part of the abstract that went out. But my objective for this session is for you all to gain a little bit of appreciation for sort of how we got to where we are today. This is normally a half day to a full day workshop, so I'm going to be very abbreviated with it. But hopefully you can get an idea of how we got to where we are today, and some problems that we have with our current system, and our plans to future the modernization of our frames. How those frames are going to be defined, and how users are going to have access to it and be able to utilize the tools that come along with datums, like transformations, etc. I just want to throw this slide out for those who are not familiar with the National Geodetic Survey, or familiar with the what used to be the State Advisor Program, now a Regional Advisor Program. Excuse me. Regardless of where you are in the United States, could be Alaska, could be somewhere in the Pacific, there is a regional advisor, other than the Appalachian and the Northwest, which are currently vacant. But there is a region that you live in, and someone who is assigned to help you out. So if you haven't met or introduced yourself to your regional advisor, I encourage you to get on the NGS website, find their contact information, and feel free to hit them up with questions should you have any. So U.S. Department, oh, what the heck? Sorry. Yeah, the Department of Commerce, National Geodetic Survey. Our mission is to define, maintain, and provide access to the NSRS, the National Spatial Reference System. The reason for that is to meet our nation's economic and social environmental needs. Some people they have a hard time seeing NGS and its connection to the Department of Commerce, but if we go back in our nation's history, accurate mapping of our coastline, for instance, was critical to commerce. If we couldn't ship goods and services safely, then our system of commerce would break down. So the National Geodetic Survey, previously the Coastal Geodetic Survey, was part of the Department of Commerce and still is today. The National Spatial Reference System is a set of quantities, some of which you're probably familiar with: latitude, longitude, height. But we have these other values: scale, gravity, orientation, and more importantly today, our acknowledgement of how they vary in time. As we know, as much as we enjoy thinking that we live in a static world, I think we all probably realize that the world is not static. Even regionally, we have motions and things that move. So the fact that coordinates change, that's part of our definition. We have to be able to incorporate those changes with time. So we've had a few different types of datums, and still do today. We have what we've classified as a horizontal datum, right? Two-dimensional, latitude, longitude, ellipsoid. Northing, easting, and really our last real horizontal datum really was NAD 27, or the first version of NAD 83. It really didn't incorporate any height component. Okay? Well, along with that, we had a one-dimensional or vertical orthometric height, and previously NGVD 29 and now NAVD 88, okay, and as well as local title datums. But the world we live in today is we deal with geometric datums, and these are three-dimensional: latitude, longitude, and ellipsoid height. Those typically today are if we're working in GIS or using GPS, that's all pretty much running out of the North American datum of 1983 and the current realization, which today is NAD 83 2011. And as I said, we really are in a realm today where we're dealing with our fourth dimension, when that's time. So these quantities, and then how these quantities change in time. So what is a datum? I think maybe it's a silly question, but I think it's one worth visiting. Okay, we can take an approach that says it's a set of constants specifying the coordinate system used for geodetic control for calculating the coordinates of points on Earth. I think everybody intuitively understands that as a datum. There is a second definition, though, okay, and this one would be the definition as above, together with the coordinate system and the set of all the points and lines whose coordinates, lengths, and directions have been determined by measurement or calculation. So I know that there's been a misconception over the years that when NGS has released, for instance, when we released NAD 83 2011, the general population said, "Oh, NGS has released a new datum." Okay? And so that's actually not quite true. We've released a new realization of the same datum. So it's still NAD 83. We've just changed essentially it's been a readjustment, it's been a reprocessing of data, but the coordinates, the math, their math, let's say, has remained the same. The origin of the coordinate system, meaning the Earth's center of mass, its definition has remained the same. So not truly a new datum, but a new realization of the same datum. And that's maybe just a slight play on words, but it's an important concept as we move forward to understand what we're talking about. So as I said, NGS has used the first definition. And the reason is because every time if we were to readjust our National Spatial Reference System, if we used the second definition, we in fact would have to create a new datum. And for those folks who work with contracts and legislation and statutes, you know that if to try to change something that says, if you have a state statute that says that the official coordinate system for your state is NAD 83, blah, 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 and then we change that, it makes it very difficult for the user community to keep up with those changes. It's very difficult to make changes in your documents, and it's very difficult to make changes in state statutes. So we're sensitive to that fact, and that's one of the reasons why we haven't made changes officially to create a new datum until what we're just about to talk about. So very brief history of NAD 83. The original realization was in 1986. That consisted almost entirely of classical observations, okay? Line of sight, triangulation, trilateration, long baseline taped measurements, that type of thing. In the early 90s, or mostly in the 90s, we had this new type of survey called the High Precision Geodetic Network. If you're out on the West Coast, you'd recognize the HPGN acronym, or here in the central part of the country or in the East Coast, we called that a High Accuracy Reference Network, or HARN. And these networks were based on GNSS or GPS observations. Excuse me. And as we created these new realizations of NAD 83, the GPS pretty much rose to the top, and the old classical data was then adjusted to the GPS work. In 2007, we had a new realization, one that we had for our CORS network, the continuously operating GPS reference stations. That was called CORS 96. And its companion for the National Spatial Reference System, essentially all of the disks in the ground, which was the National Spatial Reference System 2007. And that was the first time where we truly had a simultaneous nationwide adjustment of all of the GPS data that had been collected throughout the years, from the literally from the late 80s, early 90s through 2000. I think we had the cutoff date of 2005 or 2006, or all the projects that went into that. So it was a homogeneous, as homogeneous as you can get with data that spans many decades, but a homogeneous, simultaneous adjustment of that data across the entire country. And then our latest realization, NAD 83 2011, and you realize now we have this epoch, this idea of a time tag. And what that says is that the coordinates are adjusted to be at a stable location as of 2010.0. So if your date, you could take away from this that if your date is 2010.01, well, our official realization is the date 2010.0. So the idea here is to start to try to think about time tagging our data, and the fact that even though I may be tied to a particular datum, I may or may not be in the correct epoch of that datum. So my data and your data, if they're collected at different epochs, may disagree by the fact that there's been movement between those two time frames. And we'll talk about that very briefly. So why have we changed datums over the years? Okay, well, NAD 27 was based on old observations in an old system. We had Clark's spheroid. It was best fitting for North America. It worked quite well, and many folks said, why did we even have to change? It worked really well in my backyard. Well, that's great, but then we start dealing with space-based observation tools. So we had Doppler, and then GPS came along, and we had other other ways of making measurements on the ground with equipment that wasn't based on the ground. It was based in space. So a non-geocentric coordinate system like NAD27 really wasn't well fitting for NAD83. I'm sorry, it wasn't really fitting for space-based observations. So hence the NAD83 came along. And then I'll speed this along, but essentially, if we go through these different realizations, I can point to a specific piece of technology that really, whether it was truly the reason why we made the change, there's a high correlation. So if we take NAD83, 86, and we go, hey, great, that's new. Well, in 92, how come we start with this new system? Well, the reason was, well, let's even go back to NAD27. We did that already, 27 to 86. Essentially, we had space-based. We started to get lasers for measuring long distances, right, EDMs. And then from 86 to the 92, 96 time frame, let's say, surveyors and positioning professionals started to use GPS. Well, the GPS measurements that users were making were more accurate than what the coordinate frame supported. So remember, we still had a lot of older terrestrial type data triangulation that was in the NAD83. It was part of the definition of the National Spatial Reference System. So if folks went out and they did GPS observations between two of our marks, their measurement between the two using GPS was better than the coordinates themselves supported. So obviously, if we're talking about a control network, it has to be more accurate than the measurements that are being made upon it, okay, hence the change. When we have the 2007, that essentially came about because we introduced continuously operating GPS reference stations across the country. And now we have these stations that are running 24/7, 365. They're all tied together, one homogeneous network across the entire country. Long story short, the HARN network went in very much as a piecework or piecemeal patchwork type project. So we didn't have a really good homogeneous GPS network across the country. So in 2007, that was the first time where we were actually able to adjust all of the data across the country simultaneously so that it was all consistent. In 2011, we had to make adjustments to the coordinates of our core stations, and it would stand to reason that if we adjust the cores, we have to adjust the brass on the ground to agree with the cores. So essentially, we're sort of chasing technology with how these different realizations come out. Okay, along with that, there's also an implied change in accuracy. And this sort of gives you an idea of what those changes have been over time. And you can also see too that we've gone from the idea of a local accuracy, which many surveyors are much more familiar with, this one part in some linear unit, okay, one part in 100,000, one part in 1,000, that type of thing for surveys. But in GPS, that really makes very little sense, and I'm sure to the GIS community, that makes very little sense, right? Because if you have a point on your map and I tell you that its accuracy is one part in 100,000, that doesn't tell you anything. It doesn't tell you relative to what, right? Relative to this other data set that I have next to it? No. Okay, so we've changed, and we've now gone to this the National Spatial Data NSDI, or what's the acronym I'm thinking of here? Anyway, the new national standards for data accuracy, spatial data accuracy. So what do you use in your state within your GIS, right? Well, some folks, whether they desire to, maybe they have a need to, they utilize NAD27. Okay? Others say, well, we use NAD83, either latitude or longitude state plane coordinates. That's good. One. Okay, as I said, we've had many different realizations of NAD83 over the years, and though it could be splitting hairs depending on your accuracy requirements, we might be looking at a meter, maybe a meter and a half at the greatest extent between any of these different realizations. And that might be okay. Depending on how coarse your data is, you might be able to simply say it's NAD83, and that might sort of cover the ground of where that point could be. But you can see that if you have a more accurate data set, you're using LiDAR, for instance, or you're using a state's real-time network, or RTK, in order to create your data sets. You're collecting data now potentially at a couple 3 centimeter level of accuracy, and probably purporting it that way. Well, now the different realizations that those coordinates are tied to become very important, because if I'm collecting centimeter level data, and if I'm in NAD83 2011, and I simply say NAD83, users or people who have my data don't really know what they're getting, right? They don't understand. They don't know what they've got. They don't know how to treat it. They don't know how to translate it or transform it. So it's very important in order to truly document your work, to know and document which of these you're truly working in. We could have a separate argument on this. Some folks would say that they're working in WGS84 unless you're doing truly autonomous work from the satellites, or you work for the Department of Defense, or you're doing something for a military contract. I would doubt that's the case, but if it were, it would still be important to indicate which one. There have been many, many different versions of the WGS84, and they have moved at anywhere from up to from the original WGS84 to where we are today, a little over 2 meters. So if you were truly putting out coordinates in WGS84, it'd be very important to indicate which realization of WGS84 you were working in. And that would be the same for any of the international frames, International Terrestrial Reference Frame or the International GNSS Reference Frame. Okay. So I'm not going to get into the details on this, other than to say that for geodesy, geophysics, the international frames is where we work. Okay, that's the gold standard. NAD83 and all these other frames essentially are we have transformations that allow us to go back and forth, but all of our data today is really being collected from or positioned through space-based technology, which operates in these international frames. So the orbits are in the international frame, the coordinates are in the international frame. So that's where all this data is being processed. That's important from the standpoint that where NAD83 is today compared to the international frame is about 2.2 meters different spatially. So why do we care, right? I mean, as long as I can get my NAD83 coordinates, why do I care that it's different? Well, today that 2.2 meters really doesn't show up. I mean, even if you're out with, with a resource grade handheld receiver, okay, something very inexpensive like a Garmin, the level of accuracy that you're getting for those coordinates are probably somewhere in that 0 to 2 to 3 meter type range. So that 2.2 meters really doesn't show up. When you're getting coordinates, it doesn't really show up. But it won't be many years, but what you can go down to your local hardware store, pick up your Ronco Pocket GPS receiver fishing pole, and go outside and get a position autonomously just between you and the some 40 or 50 satellites that you're actually getting data from, and you get a position down at somewhere around a decimeter level. Okay, now that 2.2 meters really shows up, and this is to a great extent is one of the reasons, the primary reason why we are making a change from NAD83 to a new system. This new system will adopt more the international frame from the standpoint of that origin. So that 2.2 meters will be going away between the international frame and our plate fixed frame, similar to NAD83. Okay. Oops, I didn't mean to go backwards. Here we go. So within IGS 08 or the international frames, though, this is what this looks like. Okay, we're all aware that we have this thing called plate tectonics, and so what this does is this shows us this is how the North American plate is moving. So on the order of a couple, 2 to 3 centimeters per year in the international frame, our coordinates are moving. So the ground itself may not be moving underneath your feet, but the entire plate is moving relative to the origin of the coordinate system, which is that Earth center of mass. Okay? So that's an important thing to remember as we move forward. So now let's look at the vertical side very quickly. So most of you are probably familiar with NGVD 29, National Geodetic Vertical Datum. Its zero height was held fixed at 26 tide gauges around the country. Okay, that sounds like a reasonable thing to do, unless you're familiar with how sea level sort of works or doesn't work. Sea level is a local phenomenon. If sea level is really only sea level within a certain distance of where that tide gauge is. Once you move up the coast or down the coast or inland, you'll find that whole idea of sea level sort of being able to carry that zero sort of breaks down. So it didn't account for the local mean sea level variations, okay? Because again, you can go up the coast and zero at one gauge is not the same as the zero at the other gauge, okay? Because local sea level is affected by temperature and salinity and a lot of other physical quantities, physical influence. So this is sort of where those tide gauges were in the U.S. and Canada. Okay, so what we did really is we said each one of those tide gauges was zero. Okay, and then we had geodetic leveling across the country that tied all these gauges together, and we warped our data. We actually warped our observations to make them fit zero across the country, which was truly not the case. Okay, because sea level on the East Coast and West Coast, or even sea level up and down the coast, is not equivalent. So we came out, excuse me, in 1991 with NAVD 88, okay, which is defined as it's indicated here. Okay, so there's one mark, this Father Point Rimouski. It's up in Quebec, along at the mouth of the St. Lawrence, and it is the one mark that was held fixed for the adjustment of NAVD 88. So we took all of the leveling plus new leveling that we had across the country and adjusted it all to that one point, to that 1, 0. Okay, so the realization of NAVD 88 was over 500,000 marks across the country. Okay. So using the one fixed height, removed that local mean sea level variation that we had with NGVD 29, but it also allowed this unconstrained errors to build up across the country. So if you know anything about adjustments, survey adjustments or least squares adjustments, if you have, every observation has an error. So if those errors go unconstrained, if we don't constrain at both ends of the line, for instance, and adjust out the error, then that error is unchecked, and essentially you've got a hinge point on the East Coast, and all the observations, though the precision between the observations are very good, by the time that you get to the end of that line, all of the error has propagated to the end. Okay? So that's one problem that we had with NAVD 88. Okay? The other thing is that the zero surface that we selected wasn't really truly the zero that we wanted. We actually selected a zero because, again, we could pick zero almost anywhere if we want to think about that, right? We could say here's zero, or if you can see my hands, I'm moving it up or down. So here's zero, here's zero, here's zero. We selected zero primarily so that the U.S. Geological Survey didn't have to redraw all their contour maps east of the Rockies. So there was an economical reason for us picking a particular zero for NAVD 88. Okay, now let's quickly just look at the other way that we define heights today, or ways that we determine heights. And this is something that you've probably all seen before, this little That's funny that that didn't it didn't play the way it was supposed to. So if we can look here, if we follow my mouse, I apologize. This was supposed to this is all supposed to move for me. So here's the heights that we get. This yellow line is the height that we get with GPS. This is our height above our reference ellipsoid. Okay, so here's our reference ellipsoid, which is a GRS-80 ellipsoid. This is what we measure our GPS measurements relative to. Okay, this is the height that when we go out and we do leveling or we tie to an NAVD 88 benchmark, essentially this is what we're trying to do. We're trying to measure along this plumb line perpendicular to the geoid up to the surface of the Earth. Okay. Well, we can't get that directly with GPS because GPS measures relative to this ellipsoidal surface. So we have this other quantity called the geoid height, or a geoid model. I apologize, my dog's going to bark at the electrician outside. And we have this this model that tells us the difference between the ellipsoidal height and the geoidal height. So that's called the geoid separation. So when using GPS, we can say that the ellipsoid height is equal to the orthometric height plus the geoid height, or more often than not, we say we're solving for the orthometric height, so we'd say the orthometric height is equal to the ellipsoid height minus the geoid height. Okay? And that maybe looks a little funny, but you have to understand that the geoid height, by definition here in the United States, is negative. Okay? So that equation actually works out correctly. The other thing that we have to think about too, and if you're started to work with elevation data, or more specifically probably with LiDAR data in your GIS products, you may run into this thing called a geoid height, and you may run into things called ellipsoid heights, and it's good to know what those relationships are. But like NAD83, it's also important to know which geoid model should be used with which set of ellipsoid heights. So hypothetically, let's say that a project is being collected with LiDAR. Directly out of the LiDAR observations, you're going to be getting ellipsoidal heights because the orientation of the equipment in the airplane is based on GPS, which is measuring ellipsoidal heights. Okay, so initially, that's how that product comes out, is all ellipsoidal height returns. And then that data gets reduced using a particular geoid model. Okay? It should give you, for instance, an NAVD 88 orthometric height, which is what you all want in your GIS for doing your work. So I won't go into the details as to why, but for instance, NAD 83 2011, if you have NAD 83, oh, excuse me, NAD 83 2011 ellipsoidal heights, you would be using geoid 12B as the most current version, using geoid 12B to reduce those to NAVD8 orthometric heights. If you had older ellipsoidal heights that were tied to NAD 83 2007, you'd want to use geoid 09. If you're working in Alaska, geoid 06 could be important to you. And if you were working with the Harn versions, the NAD 83 96, for instance, and/or the CORS 96, then you could be potentially using, or could have been using geoid 03, 99, or 96, with 03 being the most current. Okay, so it was interesting because I was looking today, preparing for this, and I was talking with Drew, and he showed me some of the metadata from one of his projects, and it said that the datum, right? It said that the datum was NAD 83. It didn't say anything else. It didn't say 2011, 2007, or 1996. All it said was NAD 83, and it said geoid 09. So they had some of the metadata was in there that would be helpful, but not all of it. So one would have to assume that if they were using geoid 09, that those ellipsoid heights from the raw data, the raw LiDAR data, would have been referenced to NAD 83 2007. And based on the time frame of this project, that's probably true, but it was no better than an educated guess. Okay? Looking at the metadata from that project, one would have to guess what that data was tied to which would help you to do something with it, help you to transform it. You'd really need to know, have to backtrack to figure out where that data came from and what it was truly tied to. So a few, excuse me. So a few of the problems, okay? So NAD83, as we pointed out, is not as geocentric as it could be, right? About 2 meters. And again, you don't see that yet, but it won't be many years down the road, but what you will, okay, because of the new satellites that are going into orbit. NAD83 is not well defined with additional velocities. NAVD88 is realized by passive control, okay, and that's really almost one of the biggest problems. To truly tie to NAVD88, it means going out and touching a piece of brass, right? It means setting up a level or a total station or GPS equipment on that benchmark. And for the surveying community, they'll be the first to tell you that number one, those marks are never where you want them to be. And number two, it very well is likely marks have been destroyed or possibly disturbed. Number three, if it has been disturbed, you don't know it unless you go to great lengths to verify that it is still stable compared to the neighboring benchmarks, which may or may not be there. So the fact that we realize our vertical datum by physical monuments in the ground is problematic because they get destroyed and the ground moves. So do we truly have a stable vertical reference frame? Okay, and the answer to that really is maybe. We don't know. NAVD8 doesn't account for local vertical velocities, right? We just talked about that. So we have here in the east, we have isostatic adjustment, which is the uplift. So after we took a couple miles of ice off of the surface of the Earth from the last glaciation, the Earth is still in the process of rebounding. Not a lot, maybe a millimeter per year, but over many decades, that millimeter per year adds up. Okay? We have subsidence going on. We also have this thing called sea level rise. So if our vertical datum is supposed to reflect sea level or global sea level, as defined by least squares, and sea level is rising, then should our vertical datum somehow be able to either A, recognize, or B, accommodate that fact? Right? So these are questions and problems with our systems. We have the space-based system that's out there now, okay, called GRACE, which allows us to actually measure gravity over the surface of the Earth at long wavelengths, let's say a couple hundred kilometers, an accuracy of maybe a centimeter over those couple hundred kilometers. Okay? But it allows us to look, and using this GRACE data, it's proven that our zero surface is biased for NAVD88. Okay, it's biased by about a half a meter, and it's also tilted, sort of from the southeast to the northwest. So there's about a 1 meter of tilt in the NAVD88 zero surface across the country. Okay, so these are our technical problems. So we have a practical problem where our benchmarks are what define our datum, and as they disappear, it gets harder and harder to truly tie to our datum. But we also have this scientific issue where we know that we have these two problems. Okay, so what that sort of looks like, if we want to draw a cartoon of that. Okay, so here's our NAVD88 reference surface, and here's the geoid, really where it should be, and that's about a half centimeter in bias. Okay, and again about a 1 meter tilt across the country, and up to 2 meters in Alaska. That's sort of what that would look like. So this is the approximate mismatch of the geoid and the NAVD88 surface. So we can see that sort of going from the southeast to the northwest. We can see how that tilt portrays itself across the country. So people say, well, put in new benchmarks. And unfortunately, this is not a cartoon. This is not a SketchUp. This is the real world. Somebody thought that they really needed another benchmark right on top of an existing one. I'm not quite sure why, but hopefully, what it illustrates is that setting more marks doesn't necessarily solve the problem. This one is the one that's on top of the others. Probably no better. If one's moving, they're both moving, and they're still not in my backyard. They might be 5 miles from my backyard, so it doesn't help me in my survey. This is what height modernization is about. It means being able to remove the differential leveling, which is time intensive, it's expensive, to something where we can you know, work virtually almost anywhere. You know, as long as we can see the sky, I can have the ability potentially to get in a GPS-derived orthometric height. It's faster, it's cheaper, and certainly a lot less time intensive. So NGS's mission and vision. Okay, we talked about what that was, and our current targets are to this says redefined, but it's actually replace, is to replace NAD83 and NAVD88 with new reference systems, providing centimeter accuracy coordinates, both horizontally and vertically, virtually anytime, anywhere. We've had 2 10-year plans. Our first was in 2008. Originally, we were going to be looking to end this project by 2018. We had some budgeting issues, so that delayed us a little bit. So now we're on track for a 2022 completion, and we are truly on track. We're actually maybe crossing our fingers, actually a little bit ahead of the game, at least on our data acquisition. So what does this look like? So the geometric, remember, that's our latitude, longitude, and ellipsoidal height. Okay, our colloquially what we call our horizontal coordinates, but our geometric coordinates is truly what we'll call them. Okay, 4 plate fixed terrestrial reference frames. Have defined exactly what plate fixed means. We've taken care of the math between the international frames and our new plate fixed frames. Plate fixed frames are replacing the NAD83. We'll have a plate rotation model for each of the plates. Coordinates of the survey of epoch. Okay, remember, if I survey something today, that's really the only time that I can tell you where that point was, isn't it? If I go there tomorrow and I say, here are the coordinates, well, that's what they were yesterday. Granted, it's only a day, but maybe it's a year. Well, we know that in this international frame, that means it's going to go, let's say, 2.5 centimeters, maybe 3 centimeters. Okay, and that's just based on the plate rotation. That doesn't account for any potential local motions regionally. We also plan to develop an intra-frame velocity model, so that would take care of the interplate motions. So subsidence, for instance, which is not part of plate tectonics, could be incorporated into this intra-frame model. Okay, and would allow us to compare the coordinates surveyed at different epochs. So as we look at something that was surveyed or positioned 5 years ago, or let's say positioned in 2022, in 2026 we'd be able to see that point. We'd be able to compare the coordinates, and we'd also be able to apply a velocity to get back to an initial epoch. And I think essentially that's where we will go. I think it's on one of the next slides, where essentially we'll be able to come in and say our official, as it is today, our official coordinate system for the United States is NAD83 2011 epoch 2010.0. Well, we'll have something that will say NAD83. Well, it won't be NAD83. It's going to be the North American Terrestrial Reference Frame, NatRef 2022. Okay, and it will have an epoch. So it'll be a particular epoch date that we'll have that goes along with that. So here we have our 3 existing plate frames, NAD83 for CONUS, the Pacific, and the Marianas. Okay, and now we have these 4 frames where the Marianas are separate, and now we have the Caribbean. Okay, so NAD83 was actually the Caribbean frame was actually still part of our CONUS NAD83. Excuse me. Okay, blueprint for 2022, the geopotential side. Now, I haven't talked about that. So yeah, I thought you said, well, we're changing the vertical datum. Well, vertical datum, when we're talking about it, because gravity is essentially what is defining that datum. It truly is a geopotential datum, okay, and it will be based on a global three-dimensional geopotential model, okay, which would be essentially gravity and terrain. Okay, will contain all GRAV-D data. Gravity, and I'll define what GRAV-D is, but that's the gravity for the redefinition of the American vertical datum. Okay, we'll talk about that here briefly in a minute. Able to yield any physical value on, above, or below, for that matter, that surface. We'll be utilizing a high-resolution geoid, which would be essentially all of our gravity and terrain data, incorporate deflections of the vertical. We won't go into details on that at this point. Surface gravity products consistent with the global model. Okay, not global. We have the North American, Pacific, American Samoa, Guam, and CNMI, and time dependencies. Okay, looking at a geoid monitoring surface. So, does the geoid change? Does gravity change? Very small amounts over long periods of time, but it's something that we truly do realize that we have to track. We think that the changes could be large enough, let's say over a 10-year period, to warrant us considering looking into updates to the vertical frame or to the geopotential frame based on that. And some of the reasons for that would be impacts from deglaciation, sea level rise. So as we're taking the masses among all that are currently on the Earth, and those get redistributed because of glacial melting, etc. That affects the gravity field in different parts of the Earth. Okay. So on the vertical side of the geopotential side, we have all of our NAVD 88s. We have our one NAVD 88, I should say. We also have vertical datums, which are essentially they're normal orthometric heights, but they're tied to local sea level on these islands. So Puerto Rico vertical datum, Virgin Islands, Northern Marianas, Guam, etc. Okay. We also, if you work in the Great Lakes area, there's this other datum, which is a dynamic height datum called the International Great Lakes Datum, which is also going to be updated around the 2020-2022 timeframe. Okay, we have gravity, we have geoid undulations, deflections of the vertical. All of these models now end up right here. So we have one vertical datum, one geopotential datum that literally goes from equator to the pole. So covers about 1/4 of the Earth's surface. So for the first time ever, we could really actually relate heights on the west coast to Hawaii if we want to, at centimeter level type accuracies. Okay, maybe not 1 or 2 centimeters, but centimeter level. So there was no way to do that previously. I couldn't tell you what the NAVD 88 height was in Hawaii because there was no way to establish an NAVD 88 height. My good friend Dave Doyle used to say, unless God Almighty is your rod man, you're not leveling to Hawaii. So, there was no way to physically make a connection between these different areas. We'll have a new geoid model that will go along with that. Okay. So our future frame, cores base. So based on our geometric frame, based on our continuously operating GPS reference stations, okay, using GPS, GNSS. Coordinates and velocities both in the international frame and the official datum. So essentially our official datum will be identical to the latest version of IGS, the international frame that's available in 2022. So the latest version we have and a particular epoch. So our datum and the international frame will be coincident at that point in time. Okay, and then over time they will separate slightly, and then we'll have to become a maintenance issue or a velocity issue. Okay? We can always just let that frame continue to drift and have a velocity that allows us to move our coordinates forward and backward in time. We're replacing the NAD 83 frame by 2022. Passive control, so our benchmarks, our marks on the ground, the horizontal marks on the ground, are now tied to the datum. They're not the definition of the datum. Okay, it addresses our needs for coordinate constancy versus accuracy. And I think you can appreciate that if I want to keep everything constant, I lose accuracy, right? Because I don't change my coordinates, but things are moving, so it's not reflecting things. And then accuracy, of course, to keep the accuracy between points, I have to accommodate for the fact that the Earth is moving. Okay, so then constancy goes out the window. So we can't have both. Latitude, longitude, ellipsoid heights, defining points, millimeter, let's say centimeter, anytime. Course coordinates computed and published daily. We do that right now. Okay, and everything we do will also continue to support the development of real-time networks. Our future geopotential frame, replacing NAVD-88, gravimetric geoid base. So it'll be solely based on gravity. I won't go into how our current geoid models are defined, but essentially they are biased and forced to fit NAVD-88. Remember NAVD-88? It's about a ½ meter off and about 1 meter of tilt. Well, we've forced our geoid model to fit that inaccurate surface. So now we're going the other route where we'll be using just pretty much pure gravity and letting things fall where they should. We'll have transformation tools for NAVD-88. So if you've ever done any work with heights, you may have used a model that we have called VertCon that allows you to go between NGVD29 and NAVD-88. Well, we'll have a new vertical transformation tool to go to the NAVD 2022 heights. Okay. So this essentially is how you will access it. So it won't be going out and finding a benchmark and then leveling from that benchmark or setting up GPS on that benchmark. It'll be utilizing the cores. You'll do some kind of a survey, maybe using NGS's online positioning user service or something similar. You'll establish an ellipsoidal height using these core stations. You'll apply the new gravimetric geoid model, and you come up with your new NAVD 2022 orthometric height. Okay, so that's how you will realize the datum. That's how you'll establish heights in the datum, would be directly from the ellipsoidal heights from the core stations. Okay, those passive marks won't go away. They'll be considered to be secondary access, realizing that they're always moving. And there's no way for us to know how much they're moving or when they moved. So it can still be used, but it certainly will be at your own risk. We will have very little to no maintenance for those marks. So if we go back to our little picture that says that if I want an orthometric height to a centimeter or two, let's say 2 centimeters, and I can get an ellipsoidal height to within a centimeter, then I need to have an a geoid height to a centimeter, right? So 1 centimeter of error here plus 1 centimeter of error here allows me to have 2 centimeters of error here. Okay? So the gravity for redefinition of the American vertical datum is that's the GRAV-D project. That's what's going to get us hopefully our 1 centimeter accurate geoid model that would allow us to get our orthometric heights, our NAVD, or what were NAVD-88, but now NAVD 2022 orthometric heights to a couple of centimeters. Consists primarily of airborne gravity. So if you're familiar with LiDAR or photogrammetry, similar type of process, just different technology in the belly of the plane. Instead of a camera or a laser, it's a airborne gravimeter. We'll be looking at long-term monitoring of the geoid change over time. So what will GRAV-D do for us? We're going to redefine this H0 surface. We've actually already done that in cooperation with the Canadians. We've agreed on a new zero that both the Canadians and the United States are using. The reliance on the passive marks will do into the secondary, as I indicated. We'll have a conversion. I mentioned that. Okay, so a new version, essentially, if you will, of VertCon that allow us to go to the NAVD 2022 heights. And that will be done by establishing, we already are well underway for doing this, of collecting GPS-derived ellipsoid heights on existing NAVD benchmarks. That gives us a co-location model that allows us then to use those ellipsoid heights and the published orthometric heights to determine what the transformation would be for the new vertical model. This is sort of, again, what the changes we're looking at across the country. So here's your approximate predicted change from NAVD to the new vertical datum. Okay, so we can sort of see how that goes, and that looks very much like what? Looks very much like the tilt in NAVD, doesn't it? So I don't think that actually should be much of a surprise to folks. We saw where the problems with NAVD were. This new change hopefully should resolve that. So in my part of the world, here's some predicted changes. So for horizontal coordinates, we're looking at a change of about 4.1 feet spatially. Ellipsoidal heights at about an order of a minus 1.15 feet. And then our orthometric height changes, so our NAVD to the NAVD 2022, in my part of the country would be about 0.37. Okay, but in your part of the country, you could just sort of take a look here and get a rough guesstimate and interpolate sort of what you think it would be. So if you're in the Pacific Northwest, you'd be looking at, somewhere maybe around a meter. So the orthometric height changes between the datums would be about a meter. So metadata, here's where the important part is, okay? When you're collecting data now, when you're executing contracts for new spatial data products, make sure that this is an important part of what you're getting. Make sure that you've got the datum, not just the datum, but the datum tag, right? It's NAD83, what? 2007, 2011. It's state plane. Is it state plane meters? Is it state plane feet? If it's feet, is it international feet or is it U.S. survey feet? Okay. The epoch. It's really important whether the datum itself has an epoch, but to make sure that the data itself says when it was collected. Okay. If we're looking at being able to apply in the future velocities to points, then it's important to know when that data was collected. It's equally important to know what datum it was on, right? But I could collect data on a datum, over a 10-year spread, but those epochs are considerably different. So that's an important part of it, and also the source. I hesitate to say that maybe not so much in a GIS product, but certainly within a survey product, that if I gave you a set of NAD83 2011 coordinates, and you were going to use those or try to tie into those, you need to know how I establish those coordinates, right? And I mean, I can be very vague here and say, oh, yeah, I scaled them off of a quad sheet. Well, if that's what you did, then it's important for me to know that, because there's an inherent level of accuracy or inaccuracy to the method that was used. You could say, I use GPS. Okay. Did you tie into an existing monument on the ground and use GPS? Did you use cores? Did you use somebody's real-time network? Did you post-process your own data relative to one of the core stations? If so, which core station was it? So all of these things that go into how the data was actually collected is becoming really vitally important in order for people to either use or tie into or assess their data relative to yours. And if at all possible, maintaining your original survey data is critical. If all I have is coordinates, the best I can hope for is a decent transformation. If I have my raw data, I can always go back and reprocess it using new coordinates, using new models, et cetera, et cetera. So if your original raw data is maintained and kept, then using it maintains the integrity of your survey. If otherwise, again, all you can hope for, best case scenario, is a decent transformation. Okay. Oops. And again, so I think the last thing here is state plane coordinates. By statute, I think almost every state, it's dictated by statute what coordinate system is being used or needs to be used for your GIS products as well as for surveying products. And this is something I know that the National Society of Professional Surveyors, the American Association for Geodetic Surveying, and NGS is working together to define model language for state legislation to help you incorporate these new datums into your statutes, and hopefully do it in a way that that works well for everybody. So that's what I had for my prepared presentation, and I'm happy to take any questions if any came in.
Yeah, we've got some questions. Dan, man, that's some heavy stuff. I think as the geospatial community is starting to figure out, moving forward as we approach 2022 and the new datum, we're going to have to do a better job of asking questions and requiring more of our data providers, right?
Yeah, I think it's important, and we don't have to make it onerous. It's just a matter of having the knowledge, because if I don't know what I got, I don't know what I can do with it.
Right.
And we're at that point in time where, you know, because we're all in the habit of a data set comes in and our software goes, oh, here, I got this, I'm going to do this to it, and I'm going to put it into your map, and it all takes place on the fly. You have no idea what's happening in the background. You don't know if the coordinate file was properly generated or if it accurately reflects the data itself, and it's everything's just gotten so black box that we don't question what's going on in the background. And we've all probably seen problems when these things happen, and half of it is knowing that the problem that even exists. Right, for sure.
Hey, do you know if these reference frames will be addressed in OGC's OpenGIS Coordination Transformation Services at all, or?
I don't know. However, I would suspect that the answer is yes. I do know that we want to start to create on NGS's side. We've discussed having web services and that type of thing where all of the computations aren't necessarily taking place on the user side, but they're reaching out to our server to do the heavy lifting potentially. And with that said, too, I know that next fall, NGS is having I think we're calling it Industry Days. So where we're starting to really talk with the manufacturers, both on the survey, the engineering, and the GIS or geospatial side. So I'm sure that it's something that's going to be discussed. I don't know. I haven't heard anybody say yes, it's happening, or no, it's not. But I would suspect that it would happen.
Okay, perfect. Will the new datum be applicable in North America? And if not, why?
I'm sorry, will the new datum be what?
Be applicable in the U.S., Canada, and Mexico?
Yeah, the new datum really will be, it's applicable anywhere. I mean, I can create NAD, even NAD 83 today. I can create those coordinates in Mexico if I want to.
Okay.
Canada currently uses NAD 83. They have their own version, but essentially it's equivalent to ours. But I'm not sure what was meant by applicable. But but North America, we'll have the NatRef 2022 that covers the North American plate, and then we have PatRef, which is the Pacific plate, and then CatRef, which is the Caribbean, and MatRef is the Marianas, and so on.
Right. That's probably addressing the question a little more directly, in which plates are referenced, and are the changes going to occur for each plate? And I think the answer is yes for that, right?
They will, yes. And the other thing to remember is that the beauty of this is that because all these plates are tied together mathematically, okay, and precisely, right, I can survey in NatRef, which is the North Pacific or the North American plate model. I can use that in any of those other plates, because the math exists. So Yeah, so not only is NatRef applicable to the North American plate, NatRef could also be applicable to the Pacific plate because we have the velocities in the plate rotation models, and we can relate one to the other.
Okay, yeah, that makes perfect sense. Here's a question that's a little more specific to construction design. How much of a difference does the ellipsoid and geoid height calibration affect a construction design?
I'm not exactly sure where they're going with that, but I'm going to take a stab at it.
Okay.
For construction design, it could make a big difference if you. And I'm going to go with the assumption that what the questioner was asking was how much trouble could I get in if I was using one version of NAVD or 3 ellipsoid height and a different geoid model as opposed to the correct one. And you could put, and I apologize, I'm going to speak in metric here, but
okay.
you could very easily put, by mismatching the ellipsoid height and the geoid heights, you could pretty easily put the better part of a decimeter of error into your heights on project if you're determining them with GPS. If you're not really careful to make sure that you're matching up the ellipsoid height and the geoid height, you could be throwing as much as maybe 8 centimeters, 10 centimeters in there.
Okay, gotcha. For those that are still on with us, I want to remind you that this webinar was recorded and will be available at gita.org within a week or so. Dan, I'm getting some questions about access to the PowerPoint. Are you able to share that PowerPoint?
I am.
Okay.
Yeah. Let me throw this out. If within about a week or so, if folks go to the NGS webpage and then they select under Education, it's one of our top tabs on the top. Under Education, and then look down the list under Education, and you'll see the NGS Presentation Library.
Oh, perfect.
Okay, or just search for NGS Presentation Library on our webpage, and that'll bring up all the presentations that we do. So you can look for this one specifically, or search by my name, and you'll be able to find it and download it. I'll probably put it up there as a PDF. But if somebody wants the PowerPoint directly, specifically, contact me offline. I'll see what I can do. It's a little bit big for me to try to dump onto our server from here.
Right. Hey, Dan, do you mind going back to the very first slide of your presentation that's got your contact information on it, so that we can share that out?
Sure.
And then, as we're starting to wrap up a little bit, is there anything that the geospatial community can do by engaging with NOAA and the Geodetic Survey to help with this process? Can we share data back to the Geodetic Survey to run through process? Trying to figure out how this engagement could work better for both of us.
Sure. There's a couple of things. I think, well, this suggestion is geared more towards surveyors, but a lot of your folks probably work in shops where you either have your own GPS equipment, or you may even have surveyors on staff. But one of those things that I mentioned from the on the Geopotential side is that for our new vertical transformation model, what it requires is that we have GPS-derived ellipsoid heights on published NAVD 88 benchmarks. And so there are ways that you guys, as a community, if you have the right type of GPS equipment, can go out and observe those benchmarks, and then there are ways for you to share that data with us, where we have some using our online positioning user service and sharing that solution. And so that allows us then to capture the ellipsoid height that you determined on those benchmarks for us to use in that transformation model. So that's one thing that we've recommended. And if this is something that people want to do, I encourage you to either reach out to myself or to the geodetic advisor in your part of the country to sort of guide you on that process and help you to get up to speed as far as what you want to do. It's not real difficult to do, but you do have to do things a certain way in order for us to actually take advantage of that data sharing.
All right, very good.
Yeah, as far as everything else go, I don't know that there's a lot that you can do other than to just to engage us. You know, if there are questions, issues, um, horror stories that you think, oh, here's something that's happened. How can we try to design the interaction of all of our products and services and everything so that we don't have these problems happening again? So, you know, I think any of these kind of things, you know, we certainly want to hear about. You know, not that we like to hear horror stories, but that's where we learn from, and say, oh yeah, you know what? If we did this a slightly different way, then that might not happen. So, yeah, I think just talking with us and letting us know what your concerns are, what your issues are, so that we can help incorporate that into our final products. Make sure that we don't you know, we don't create things that are unusable for our user community. That would just be bad practice if we did that.
Right. I think that's a huge challenge to the geospatial community as it is to really encourage the GIS professionals to reach out to the Geodetic Survey or to NOAA when problems exist, to just to let you know that problems are there. So
Absolutely,
I would really challenge my colleagues to do that in that case. Hey,
yeah.
Dan,
Yes, sir.
Go ahead.
Oh no, I was just going to say that, and again, for you folks online, you know, take advantage of your regional geodetic advisor. You know, when you have questions or concerns, hit them up. That's what they're there for. I engage with the folks here in the Northeast, the GIS professionals in the Northeast. I'm not going to say every day, but on a regular enough basis that you know, that it's definitely, I think, meaningful for them, and it helps me to know what your issues are. It helps me to know what you guys are thinking and how you think it. So it helps me to to create better products and to provide better service for all you folks too.
Right, for sure. And if you could share that link out with me to where the presentation is going to be at the educational portal for NOAA, I'll see if I can attach it to the webinar recording at gita.org as well.
Perfect.
So it's kind of a little more streamlined for our users.
Yeah, I'll send that out after we get off. I'll just give you the raw link, and then that'll get you to the library, and then you'll just have to search for this presentation.
Yep, perfect. That sounds great. Dan, I don't have any more questions. Is there anything you'd like to follow up with before we shake hands and say goodbye?
No, I don't think so. Other than I want to thank you for the opportunity to talk to your audience. I hope it was meaningful for them and they got something out of it. And more than anything else, I hope it made them start to ask questions, because that's what this is about. This is not a one-time educational experience. It's finding out things that you didn't know and then asking more questions and learning more. So hopefully this is just the first step in that process.
Right. I think it's done that and more, Dan, and I really appreciate your time this afternoon and reaching out to our users. And like you, I hope this starts the path down towards that integration in 2022, and I'm looking forward to learning more about this. I really appreciate it, man.
All right. Well, thanks a lot. I appreciate the opportunity.
All right. Thank you, Dan, and thank you all very much for participating. And if there's anything else that we can do to spark your interest, please let me know. Y'all have a good day.